this as well, and then I'll catch up with you all for the 10th lecture.
Okay, perfect.
All
All
right.
right. Happy Diwali. Okay, so
Happy
what
Diwali.
about others? I think, okay, so I'm not going to explain the inflation thing once again. What I want you all to do is ask me specific doubts and then I'll cater to those doubts. Does that sound cool? And where you haven't spoken?
Ma'am, actually, then I haven't revised yet.
So should I just cancel today's lecture and we can keep a lecture tomorrow so that you all can revise today? So we were supposed to have a 2-hour lecture right now, right? So I want you all to revise today from now till 7 at least. Can I expect that? Can you all go through the lecture, the 8th recording which I have just put up? Maybe go through it again if you have forgotten it. And if someone has doubts, you can ask me.
Ma'am, otherwise, if it's okay with everyone, can you give us like 15-20 minutes? We will do it right now and then we can continue with the lecture.
I'm fine with it. So take as much time as you guys want. How much time do you guys need? We can actually do the doubt session as well once you guys have revised. How much time do you
I think
need?
it would be fine if you just went through the over the concept quickly just once, because I think in the last lecture in the starting part we just did the formula, like the z square we did
Exactly.
it. Yeah, we substituted it and all. So that wasn't like, that was just technical. So I don't think that really needs much revision. Most of the time we did the other part only, inflation related.
Okay. So maybe what we can do is, okay, let me do one thing. Okay. Let me just share my screen. Let us start from the beginning. I want each of you to volunteer and explain me what's there on each of these slides. Can you all do that? In just a line or two. Not going through or walking us through everything, but just the big picture idea. So let us all revise together. Is that okay?
Yes, ma'am, that works.
So let me probably start. So we started off with the reinsurance chapter, and we saw that there can be two types of reinsurance, which at least we will be studying in this course. One is proportional and the other is non-proportional. So in proportional insurance, we know that the ceding company, which is the actual insurance company, gets only a part of the claim amounts, and the reinsurance company gets the other remaining part of the claim amount. So this C is going to be a number which is likely to be, which is always less than 1, which is why a first share goes to Y and the rest of it goes to Z. And this C is the retention proportion, which is decided by mutual agreement. And the treaty dictates the value. And when we have non-proportional, we have a retention limit M, where if the claim amount exceeds the M, it depends again on the kind of treaty you have, but if you just have X greater than M, then the rest of the amount which is after M will be paid by the reinsurance company, and the amount up until M will be paid by the ceding company. And if it's less than M, then the whole amount will be paid only by the ceding company. So the claim will be incurred only by the ceding company. And then we saw these graphs. This was for the excess of loss case, which I just explained, I guess. And again, remind yourselves of the distribution we have for insurance company and for the reinsurance company. So if X is less than or equal to M, I know that the insurance company will incur a claim amount of X. But if the value of the claim amount exceeds the retention limit, have I started the recording? Yeah. So if the claim amount exceeds the retention limit, then the company will only pay the limit itself. And the part above the limit will be paid by the reinsurance company. Does this make sense?
Ma'am, in the graph that you've drawn there,
Yeah.
What is represented on the X and Y axis?
Okay, so here what I have written is M to M, right? So this is the claim amount, right? And this is the claim numbers, number of claims that have incurred for each particular claim amount.
I think you labeled it the other way around.
Have I? So
The
wait, so
hashtag is there on the vertical axis, so I think it should be there on the X axis, right?
makes sense, makes sense, makes sense. Because this is clearly not the number, right? This is clearly not the number. So this is the amount because this is M that we have, and this is 2M. So these are the bars that we have drawn for how many of it we have. But again, I think you guys get the gist of it. And who was that speaking?
Isha ma'am, got it.
Very well, Isha. Thank you very much. I'm so happy to listen to you today. Okay, fine. Next slide. Anything else? So again, you can devise another treaty wherein only a part of which is greater than M but less than or equal to 2M will be incurred by the reinsurance company. So you will again have a distribution like this and something like this. Next up, we looked at the expectations, the variance, and the MGF. So basically, we were trying to figure out the moments of the claims incurred in the case of proportional reinsurance. So we saw that if we have Y, which is the insurance company's claim incurred amount net, and this X is the actual claim amount, the gross claim amount, and this Z is the reinsurance company's net claim amount. So expectation of Y will just be expectation of C times X, and C being a constant will just come out and we'll be left with C times the expectation of X. And similar thing happens for expectation of Z because even 1 minus C is just another constant. And we also see that expectation of X is equal to expectation of Y plus expectation of Z. But this does not hold in the case of variance. Can someone remind me of why this is in the case in the variance?
We discussed that it doesn't make sense to add up the variances.
Exactly right. I think I drew some graphs as well. So this is what the variance represents. So it changes, it varies, but it may not necessarily add up always. So thank you, Isha, again. And then we looked at non-proportional reinsurance. And again, at its expectation and variance. So we also figured out expectation of Y square. But again, what happens in non-proportional is the value of this small x differs on the case-by-case basis, depending on whether your claim amount exceeds the retention limit or not. So if it exceeds, then the amount paid by the insurance company, the ceding company, is M. So remember, we are calculating expectation of Y, which is why we look at this distribution. So we have M here and the chance of it occurring and dx. So here we have f of x and we are varying x from m till infinity. So this is just measuring the chance of we incurring a claim amount of m. So it isn't exactly saying that the claim amount is m, but the claim amount incurred by me as a ceding company is m for all of these values of x. And f of x will simultaneously be taking different values as in when you change the x and you integrate it all over to sum it all over. So that's it. It just summarizes the expectation of y, and this is the usual case for 0 to m case. So if you have 0 to m, you pay x. So this amount also varies with the x here, and over here it was just constant, the retention limit itself. And then you can take that outside, and this is just the probability that your x takes a value greater than m. And you do some calculations thereafter. But here we are calculating expectation of y square. So you have x square here and m square here respectively. And then again, you go on to figure out its moment generating function. And it is kind of similar. But what we have to remember is just the fact that, we have y here And Y can take two separate values depending again on the various cases. So it takes the value X if my claim amount X is between 0 and M, and if it takes the value M if my claim amount is between M and infinity. And then again, if you have to calculate variance, you know the formula. What was this? Oh, this is the Boyle example. Okay, again, I have the book with myself, and I'll maybe clarify the confusion we had here later. So, okay. And then we looked at this. So this is very important because we do know that, not every time the reinsurer will know all of the claim amounts that have incurred. So it might only know the claim amounts for which it has to do some business with, not everything else. So that is why we also look at the conditional distribution of the claims incurred by a reinsurance company. Does anyone remember what was the bigger picture of this? Like, I don't want you to walk me through the derivation, but what was it that we concluded here? Yeah, what was it that we concluded here? Not there, here. Does anyone remember? So can I at least have a yes or a no? I'm guessing silence means no here. So again, just to remind ourselves that we do not have to remember this Bayesian formula. We can always draw the Venn diagram and logically see the formula for ourselves here. And again, because we're looking at the conditional probability, because the reinsurer will only know a claim amount if it is greater than M. And what happens is we don't really have to do anything else, but just use the formula and the logic. And instead of doing this whole derivation, which I think if you probably go over once again, you will understand what we did here. But the gist is this formula. And we don't even need to go through this, all of it, to remember this formula because this makes sense. So what is f of w plus m? Remember, we defined our w as something which is x minus m. So when we looked at our reinsurances distribution, we see to it that, if my x is greater than m, then the amount paid is x minus m by the reinsurance company. So again, I define that x minus m as some random variable w. So now W represents the claim amount that is incurred by a reinsurance company, right? And again, it is X minus M, which includes one random variable, and this M is just a constant. Just to remind you guys again. And yeah, so again, what you do next is you redefine it in terms of Z, but we're going to forget about that. We'll have a look at, the intuition of this formula. So this defines the PDF for the reinsurer's conditional distribution of claims. So in our heads, what we have is that the probability that X minus M takes a value less than W, given that X is greater than M. So again, I have not written here maybe, but maybe I should write it. So this is F with respect to X, okay? And this is also F with respect to X because we have a random variable X here. So it is not with respect to W or something else. So we used G to represent the function, the PDF for the reinsurance company, and F is what we denoted as the function for the X, which we already are aware of. So what happens is, what we see is the claim amount which is incurred by the reinsurance company is small w. So this is the random variable's value which we are trying to figure out the probability of, right? What is the chance that there will be a sum of this small w's claim amount incurred by the reinsurance company? So what happens is you just rearrange it in terms of x and you write the probability that this x happens. Because you know that this m is a constant, the chance of this w happening is actually equal to the chance of this x happening. I mean, not exactly, I would say equal, but similar. Similar is the term I would like to use. And then again, I would just write my f of x, w plus m here, and then I'll write 1 minus f of m. I think I remember we had a discussion as well about if, I think I erased that, but it's there in the recording. But yeah, and this is just the probability that your x will be greater than m. So that is the intuition behind this formula. And then we also looked at how to figure out its moments and everything else. So if you do the calculations, you get something like this, which is again the value that it has to pay, the chance that it will occur, varying from 0 till infinity, all the values that x can take, and probability of x greater than m, which is what we're conditioning upon. And if we redefine z as x minus m, we get a nicer equation for the expectation of w. And that's it. We have expectation of z upon probability that x is greater than m. So z is, remember, just x minus m. All right. And we were conditioning upon the fact that it is greater than 0. Yeah, so then we had a look at an example where claims followed normal distribution with the mean 500 and variance 400, and the retention limit was 550. And what we looked at here was we were trying to figure out the expected claim amount for the reinsurance guy, because we have expectation of Z here. So can someone walk me through what we did here? Any one of you?
Ma'am, we first wrote the distribution of Z as when x is less than equal to m, it is 0, and when x is greater than m, it is x minus m. And then we used it in the expectation formula. And we were having trouble solving integration 550 raised to infinity x f of x, for which there is some formula in the table.
Yeah, exactly. So if you go to page number 18, if I'm not wrong, of the table booklet, you will see the formula up there. Yeah, it's 18. For us to solve this guy right here. Perfect. And we got some answer basically. That's it. Yeah, then we also had a look at these treaty questions. So there was this first treaty which was about proportional reinsurance, and the second treaty which was about the non-proportional excess of loss reinsurance. So what happened was, I guess we only looked at its expectation and we discussed a bit about variance, but I didn't really figure out the answers for variance. And I guess only Mihir has sent me the answers, and his answers are correct. Very well done, Mihir. And I'm expecting the answers from you all within a day or two, I would say. Not more than that. Okay. So, I mean, if you guys are considering that this subject is really easy, it's not, and it will take, continuous efforts and continued practice and continued dedication to even, understand the concepts really well. And if you want to pass exams, just not to pass it, but pass it with confidence, with the understanding of the subject much better, which is, I think everyone should, which is what I think everyone should be aiming for at least. I think you need to revise at least what we are doing today, maybe a week later or something. I mean, because I know that if we don't revise it, we will tend to forget it. I mean, again, we have the Pareto rule here, 80-20 principle. So again, I guess, just reminding you guys to revise from time to time on spaced intervals. So, I mean, that is what I used to do for my case. But again, I know that each one of you can study in different way, and some of you might not even need to revise. But seeing the situation today, I think at least you guys should revise everything. And I will have a lecture tomorrow as well as day after tomorrow. Is that fine with everyone? We'll discuss the timings at the end of today's class.
I'm not on Sunday, please.
Why?
We have, at least I have a lot of assignments due.
So if I remember correctly, I think in December you will even have more assignments, right?
That time there will be the exams, not assignments.
Okay. So I guess then one lecture I'll take extra in the, I mean, what about others? Are you guys free on Sunday? So on Sunday, what I was planning is we can do a question from the chapter number 1. Because I remember saying that I wouldn't take a lecture during the Diwali week, but even I was very busy with the festivities. And I didn't think it would be, this much because of the COVID. But yeah, well, I didn't really take that into account. But people can be irrational, and so was everyone, I guess, during Diwali. But again, I think on Sunday, Isha, I don't see to it that you would have a problem watching recording because we'll just be solving a sum from the from the chapter number 1, loss distributions. So I'll not teach anything new. Is that fine with you?
When will the lecture after that be?
Monday or maybe Tuesday. I'll give you guys a break for a day, I guess. Tuesday.
Okay, I'll try to catch up. If possible, I will attend it on Sunday so that I don't have to catch up later.
Yeah, I guess, I mean,
Keep it on Sunday.
I will not expect answers from you. You can just keep that playing in the background and do your assignment as well simultaneously. I wouldn't mind that. I will understand your case. So that's not a big issue, I would say. What about others? So yeah, fine. Okay, thank you, Vanshita. So I'm assuming if no one else has spoken up, that everyone else is fine as well. Perfect. So again, I think that's it. And then we had a look at the inflation. We discussed the difference between rate and a factor. And we also had a look at the derivations of those truncated moments for normal as well as log normal distribution. And then I think the very important part which we covered was the intuition behind the inflation. The reinsurance when we have the case of inflation, right? So again, I guess I don't know, I guess it was, yeah, so this was about to be your homework to figure out the variance and all, but yeah, I guess no one bothered to see to it. Okay, so we looked at inflation, and again, just to remind ourselves of what happens in the inflation is that the claim amounts get inflated by a particular amount, which is the inflation factor. So here K is the inflation factor, which is why we are multiplying it just by K. But otherwise, if it would have been the inflation rate, then it would have been, what would it have been? Anyone? Does anyone remember? Hello. Hello. So I think some of you had doubts in the inflation. So do you guys remember this part at least? So what we did was we redefined the claim amount. So we know that if in the year 0, let's say, we have a claim amount of X, and if there is an inflation factor of K, then we know that in year 1, we'll have the claim amount not X, but KX. So it will be inflated by a factor of K. So again, when we are writing, the claim amounts, incurred by the insurance company, by the ceding company, the net claim amount insured, what we will have to do is we'll write KX because KX is the amount that they will be paying. And what happens is we are assuming, okay, so remember this, we assume that M remains constant. So our retention limit does not vary with inflation. So I guess I even gave you guys a little example about this, but again, if you don't remember that, I can explain that again, no worries. And it will be still M because again, so I mean, if the amount exceeds M, if the claim amount exceeds M, the ceding company is supposed to incur only the M amount. And again, because the claim amount has been redefined as KX, we get a new condition, which is KX greater than M and KX less than or equal to M. So does everyone understand this? At least I can have a yes or a no promptly.
Yes, ma'am.
Thank you, Mihir.
So what was earlier only X that has changed to KX?
Yes, yes. And what we do is, now again, we know the distribution of X very well, right? So again, what you do is you change these limits to X being less than or equal to M upon K and X being greater than M upon K, because this and this is just equivalent, right? So if we know that Kx is less than or equal to M, then we also know that X will be less than or equal to M upon K, right? So in a way, we aren't doing anything. So it looks like as if we are redefining M, but in a way, what we're doing is we redefined X and then we adjusted the condition so as to render it easy for ourselves because we know the distribution of X, which is f of X, right? And we can put up conditions thereafter. If let's say we want to figure out expectation of Y, we will have, so previously we used to have, so again, you know, if you substitute K equal to 1, let's say if the inflation rate is 0, which will render you the inflation factor of 1, and if you substitute K as 1, you will get the actual scenario. So you will have 0 to M upon nothing, and here also you will just have M. So you see that here also you will just have X. So you see what's happening is just a change in the claim amount, and which is why you change these conditions and then you get this expectation of Y expression. And it's nothing but just simple as we used to do it in the earlier case. Okay. And then we had a look at how to solve these integrals. And I think we have to use by parts somewhere here. And yeah. Then we had a look at this. So does anyone remember this paragraph? So what happens is, whenever we are looking at the case of excess of loss reinsurance, and if we are assuming that the retention limit does not vary with the inflation, so retention limit still stays the same. So what happens is, if let's say you have a lesser claim amount, which is, so maybe I think I should just take one more example today. Okay, so let us say I have my M as 100, okay? So this is my retention limit and I have incurred claims. So right now I'm considering only, let's say, 2 claim amounts. So my first claim amount was 50 and let's say my second claim amount was 120. Okay, just to make it easy, let me just make it 200. Yeah, and my second claim amount, let's say, was 200, okay? So these are the 2 claims that I have incurred as the insurance company. And my retention limit is 100. And if I say that the inflation factor is 10%, okay? So the inflation factor is 10%. So let us see what happens to the amount that I, as the insurance company, ceding company, will have to incur in these 2 cases of claims. So in first case, So let's say we are looking at year 0. What will my y be? So if my x is greater than 100, I'll be paying only 100. And if my x is less than or equal to 100, I'll be paying x, right? Does everyone agree with this? So this is the year 0 before the inflation has occurred. Does everyone understand what I just wrote on the board? Hello. Am I audible?
Ma'am, in the bottom part, it should be 100, right? Oh, you wrote it upside
Yeah,
down.
I just wrote it. Yeah, it's fine, I guess. What about others? Do you guys understand what I have written?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Thank you. Okay, so now if we incur a claim amount of 50, so maybe we can create a nice table here. Okay, so for the insurance guy, if the claim amount is 50, what is the amount that the Y company has to pay? It will be 50 itself, right? Because it is less than 100. So it has to incur the whole amount. But let's say if the claim amount is 200, how much will Y pay?
100 only.
100 only, right? Perfect. So now let us say there is, now let us say we are in the next year. Okay, so year 1, and there is an inflation factor of 1.1. Okay, so now what will happen? So this 50 will now become what number? Anyone?
Can you repeat what you just said?
Okay, so I'm saying that we have done everything for the year 0. Now in year 1, we have an inflation factor of 1.1. So the inflation rate, okay, this is wrong. So the inflation rate was actually 10% and the inflation factor is 1.1, right? So what we are doing is now, I have to figure out the claim amount for my year 1 if my K is 1.1. Assuming that the claim amounts, 55, right? For the 50 case, it will be 55. And what will it be for the 200 case?
20.
220.
220, right? It will be 220 and 55. So now let us see what happens to the distribution. Okay. So if we have 55, if we incur this claim, what will Y pay?
55.
And if I incur this claim, what will Y pay?
100.
100.
100. So do you see the starting difference? So let me just again write for ours. So in the Z case, in 50, they pay 0. And if it's 200, they'll pay 100, right? The rest of it. And here, for the reinsurance company, here again, they'll pay 0. And here in this case, they'll again pay the difference, which is 120, right? Does this make sense? So what I have written in pink is for the reinsurance company. We denote it by Z, right? Does this make sense? So again, if we incur a claim amount of 50, Y will pay 50, Z will pay 0. If we incur a claim amount of 200, Y will pay the retention limit, and the rest of it, which is 200 minus 100 again, will be incurred by the reinsurance company. And in the next year, if we have an inflation, then the claim amounts we calculated will be 55 and 220. So if we incur a claim amount of 55, Y will incur 55, Z will pay nothing because this amount is less than 100. And if Y will incur, let's say if the claim amount is 220, then Y will incur a loss of 100, and the rest of it, which is 220 minus 100, will be incurred by the reinsurance guy. Does this make sense?
Yes, ma'am.
Yes, ma'am.
Yeah. So now what's happening is, in this paragraph, what they are saying is the insurer's mean claim amount will inflate by less than K. So remember what happened here. So K is 1.1. We inflated 50 by 1.1, which was here. But remember, if you inflate 100 by 1.1, which was, so in the case of no inflation, 50 was incurred by Y and 100 was incurred by Y. So 50 को अगर हम 1.1 से multiply करते हैं, we get 55. But if we multiply 100 by 1.1, we don't get this value, right? This is same. So this value hasn't changed with respect to the inflation. It didn't care for the inflation at all. So what's happening is, for the ceding company, its mean claim amount will increase by less than K. So let us calculate the mean claim amount here. So let us say that, forget about the mean. Just see it as the total claim amount, okay? So here we have 150, right? And here we only have 155, right? So if you multiply 150 by 1.1, what do you guys get?
165.
165, right? So you get 165. In actual, what should have been an equal distribution is that the 20 extra, which is now incurred by the reinsurance company, if it were split it between the insurance company and the reinsurance 10 and 10, then you would get 165 for the ceding company here, right? Mil jata 165. But what happened here was that the claim amount was inflated by less than K, because if we get 155 instead of 165, we see that the actual claim amount which is incurred by Y is inflated by less than K, right? So the burden has increased on the reinsurance company. Why? Because our M didn't update with the inflation. But let's say if we update the M with inflation, let's say if my M was 100 prior to inflation, and after inflation, my M1 is also now, let's say 110, right? So now what will happen? So if I incur a claim of, let's say 220, then Y will pay how much? 110, right? And now if you add this 55 and this 110, you get 165, which is exactly this 50 plus 100 times 1.1. So it would be equal to K. But this case didn't happen. So this 165 didn't happen, and we were left with only 155. So that is what this paragraph says. Let me just, should I allow you guys to soak this up for 5 minutes? Do you guys want to write it down? Understood? So again, let me just read this. So we can see this by considering different sizes of claim, right? So we saw two different sizes of claim, one which was less than M and one which was greater than M. So from the insurer's point of view, which is why the amount it has to pay out on small claims, which is these like so claims like this will increase by k. So 50 multiplied by k is 55, and it did increase by k. However, the amount paid on claims that were already above the limit, which is claims like this, will not increase at all, right? It is still 100, the same as it was previously. And that is why they do not increase at all, and which is why in total its mean claim amount will inflate by less than k. Does this make sense to everyone? If you still have doubts, ask me, because I do think that this is a very important concept, and just to get the intuition of how things happen, I think this is important.
Basically, they are saying that what should have been 110 and 110. So the 10 from Y has gone to Z. So the burden of the inflation has reduced from the seeding company, and it has increased for the reinsurer, right?
Yeah, so it's like if you calculate the total burden of inflation, it is more upon the reinsurance than the ceding company. So I don't think it's appropriate to use the word increase and decrease, because in total for the ceding company as well, the claim amount has increased, but the way it weighs, for the inflation factor, it's more heavily distributed for the reinsurance company than the ceding company. But the amount,
Yeah,
the claim
because
amount increases.
because the reinsurance company has heavier claim amounts, right?
Yeah, exactly. And the retention limit is the same. It hasn't changed with the inflation. So this is the main reason why this happens. Because we saw, right, that if I change the retention limit with the inflation, then it wouldn't be the case. The burden would be distributed equally among both the companies. But we know that we are assuming that this didn't happen, which is why the reinsurance company has to incur a larger portion of the burden from the inflation. I guess Vaibhav could have actually attended this session. Does anyone still have any doubts? Anvaya, Mihir, Savri, Vanshita, any doubts with this?
No, ma'am.
No, ma'am.
No, ma'am.
Thank you. Okay, so I hope that inflation is a bit clear now. Again, let us do a sum on the inflation today itself so that this gets fixated in our minds. So do you guys need like 2 or 3 minutes to just revise in your head of everything that we just saw now? And then we can start with a question, because again, the way we solve questions is I won't directly tell you guys the answer. You guys have to come it up for yours. You guys have to derive it for yourself. And this question is particularly, I would say, not an easy question. So just take some time to revise this inflation part. Maybe I can give you guys 5 minutes. So at 6:05, we'll start with the question. Does that sound good? And also, if you guys have understood this well, then try to calculate the variance of the treaty case, and I need all of your answers for that. And I guess there were some other homeworks as well. One was about the exponential distribution, and the other one was about calculating the expectation of Z, if I'm not wrong. So yeah, I want you to do that as well. Are you all revising or solving the sum?
Solving the sum.
Okay. So again, I hope you all have, subscribed to the notifications of Google Classroom, or maybe you can install the app as well, so that, you can actually check if I have messaged or commented something or the other.
Ma'am, for the sum that you had given us, hello?
Yeah.
So for that, the treaties one, they haven't given us any distribution, right? Oh, okay.
No,
The claims distribution is log normal.
okay, yeah, exactly. You can't possibly figure out even the expectation, right, without the
Yeah,
distribution.
that's what. Ma'am, do we need the exact figures using interpolation or no?
Can you send me a picture of what you're working? I don't think we need interpolation.
For the log normal distribution thing, when we have the capital phi of the UK minus capital phi of LK. So in that, the UK is coming as 2.0333.
Let me just check. For which treaty are you solving? Treaty 2, I guess.
Second treaty expectation.
Second treaty expectation.
I'm doing the integral 0 to 25,000 x into f of x dx part.
Okay, yeah. Uh, So what is it that you have to calculate using interpolation? Phi
The
of?
phi of 2.033.
Okay.
So can we just take phi of 2.03, or for that, like,
Yeah,
0.033 exact?
it's fine, it's fine. Just take 2.03. I mean, it's fine.
Okay.
Mostly 2 decimal places is fine. We don't have to go till 3 decimal places.
Okay, and also for the lower limit, like the LK part, it will be log L minus mu upon sigma. So L over here, the lower limit is 0. So it will be 0 only, right?
Wait, for what part are you saying again?
The same part. So it will be e raised to mu plus half sigma square into phi of UK minus phi of LK.
Yeah, so again, why do you think it should just be 0?
It will be phi of 0. Because LK is log L minus mu upon sigma, right? And log
Yes.
of 0 doesn't exist.
Yeah.
So it will be phi of
But
0, right?
see, so if you see in a way log of 0, it doesn't exist. I agree. But what does it tend to? So let me maybe draw a graph. Just give me a minute. I'm trying to insert a picture. So I guess it's in. Good. So now I have this here as well. Okay, yeah. Let me share my screen. I actually inserted a screenshot of this page so that we have it in, the PDF that we have. So yeah, so Isha, what you were saying is, let's say I draw a graph for the log normal distribution. It is something like this, where this is 1 and this is y equal to log x, and if this is 0, right? So what do you think can be, in limit, what do you think can be the value of log of 0? In limit, I'm asking.
Tends to 1.
Tends to 1. Why do you think 1? So if I say 1, On y-axis, my 1 is here, right?
Oh, sorry, will it be minus infinity?
And why do you think so?
Because of the lower part of the graph.
Exactly right. So as and when you decrease your value from here till 0, it takes value. I mean, it will never be, exactly at 0, but you know that at 0 we can say approximately that it will be minus infinity. So in limit we know it will be minus infinity. So what you will get as the lower limit is minus infinity.
But how will we calculate it? Like it is log L minus mu upon sigma, right? So how can we write minus infinity minus mu upon sigma?
See, minus infinity minus mu upon sigma. So forget about this. Okay. If I tell you what is infinity plus 4, what will be the answer?
Infinity.
Did you say infinity?
Yeah, I said infinity.
Yeah. And if I tell you what is infinity divided by 4?
Infinity.
Infinity, right? And that is what you are doing. You are just adding some number and dividing it by some number. So you take minus out common, infinity plus mu upon sigma, right? So this is just another infinity and this minus sign. It's minus infinity.
Yeah, but ma'am, it's directly there in the bracket, right? So like phi of 2.03 minus infinity.
Minus infinity. It will be phi of minus infinity, right? Because minus infinity will be in the limit down here. And here you will have some another limit which you calculated. So this minus infinity will again be phi of minus infinity subtracted from whatever number you have here, right?
Yes, ma'am.
Make sense?
Yes, yes.
Good. Isn't good. What about others? What are other people doing? Mihir, what are you doing? You have already solved everything.
I was just again going through that same stuff.
Okay, good. Fine. What about others?
And what did we have to find the variance of?
Variance of,
Hmm.
as in,
Uh,
variance of the net claim amount paid by the insurer, I would say, in
no,
all
of
of the
the
cases.
same sum.
Yeah, of the same sum, yes.
Ma'am, can you confirm the answer for the variance of
Yes.
without either treaty part?
Yeah.
So I'm getting it as 41,067,200.
Oh, so again, I wouldn't necessarily be interested in your final answers. I want to see how you approached the questions. So do send me all of your workings just on
On
WhatsApp, and
WhatsApp?
I'll check. Yeah,
Yeah.
I'll check through it. So Isha, I'm just checking your variances. They are correct. And about the expectation part, I think, so what was the adjusted limits that you got here? One is 0, I see.
Yeah, and the other one is phi of 2.033, right?
Okay,
That
yeah,
comes to
that's correct.
0.9782.
Okay. Okay, I have received Savri's answer as well. Okay, so guys, I'm also thinking about this. Let us not keep a lecture tomorrow, and maybe I can keep a lecture on Sunday where we just go through some sums. Is that fine? Isha, will you be okay with it? Because if you just have assignments to complete, maybe you can do them tomorrow, right? And you can save some time for the Sunday,
Yes, ma'am, it works for me.
right? Okay, perfect. So I guess let us not keep a class tomorrow. I want you all to revise tomorrow because the sum which we will be doing on Sunday is a bit hefty, I would say, not at all easy. It will require you to use all the concepts that we have yet studied. So again, yeah, just revise everything really well. And I think it's a really good sum. And we'll also solve a couple of other sums and we'll finish up with the chapter. Maybe, maybe not. Let's see what happens. So I guess for today, let us not even start with the sum, but I'm just seeing my WhatsApp messages. Here you sent me something. Is this the variance part?
Yes, ma'am, for 3T2.
Oh. What was the mistake?
While calculating phi of UK, I haven't considered that next term minus sigma into k. So that's
Okay, I didn't check. Okay, so again, just to put it on record, whenever you guys send me the questions, I will never check the manual part, like if you have done the addition correctly or if you have calculated a figure correctly. I'll just see your steps and thinking because that is what matters. So yeah, I think again, let me see your answers. Wait. Okay, let me just write the answers, okay, for you guys. But again, I think you guys have the book run now, right? But still, I would just, write the answers out here for all of you guys to check with. And let me see once again. Yeah, so Mihir, your answer which you just sent is correct. And what was the mistake you did, Mihir? Because I think Shavri got the same answer as yours.
Ma'am, I think even I did that mistake. I didn't multiply k. Like for variance, you have to multiply 2 into mu. I didn't do that.
Yeah. So yeah, just correct that. Okay.
Yeah.
And I'll check for Isha. So did you guys make mistake in using the formula? K times mu, right?
yes, ma'am. I didn't subtracted minus k times sigma in the formula of UK in the table book.
Okay. Isha, I guess you have done a similar mistake in your expectation case.
For the 2 treaty thing.
Yeah.
What is it?
So when you're doing the integration from 0 to 25,000 of x times f of x dx. No. Here the k is 1. No. You're fine. Sorry.
Ma'am, on Sunday, can you keep the class in the morning?
Yeah, I would love to keep the class in the morning. So in my previous lectures, I used to keep class on Saturdays and Sundays from 8 to 10 on both days. Do let me know what time suits you all. The earlier it is, the better it is. Isha, can you calculate for me the value of e raised to 8.82? What is it?
E raised to what?
8.82.
Uh, 6768.26.
Ah, good. Okay, so then Isha, so you actually, so when you figured out the lower limit, did you forget to subtract the sigma from the upper limit? Sorry, the upper limit. Where is your calculation for the upper limit, by the way, for the 32 part of expectation? You haven't shown it here, right?
Uh, the thing that, like the first part of what I sent you.
Yeah.
No, I did it directly. I haven't shown it there.
Yeah, so I guess there's a mistake with that. Just check that once again because the answer should be what I'm sending you right now.
Oh, there is a minus K sigma also. I didn't do
Yeah.
that.
Yeah, so it's like, when you solve these questions, that is when you realize the common mistakes that we are bound to make. And
Yeah.
these mistakes happen with like everyone. But again, the more you solve it, the more you realize the general mistakes you are more intended to make. And then you can be aware of those while the actual exam. So just do a bit of that again and I'll check what you just sent.
Ma'am, K is the same thing from X raised to K wala part, no?
Yes. So you just have to subtract 0.8 sigma. And remember, it's not even, sigma. It's not sigma square. And always, show each of your calculations stepwise, as in when you're doing it, so that it's even easier for the examiner to see. And then they can actually see, where the mistake has happened, and maybe then they won't cut all of your marks. Because at least they'll know that you have understood the concept and just if something in the formula you missed or some numerical error. I would say the same thing will go for your variance as well. Did you forget to subtract K sigma over there.
Yes, ma'am, I didn't realize that it was there in the formula.
चलेगा चलेगा कोई बात नहीं. So do a bit of that again as well, okay? But again, I'll just write the answers on the board.
Yeah, it will be really messy after I cut it now. So I'll just send you the answer.
Yeah, just do it again and send me the working, okay? All of you are working, and maybe I'll just.
It will be really messy because I'm just cutting it and doing it there itself.
Why? Why? No, don't do that. But again, I think it's fine as long as you understand the concept. I'm fine with it, and I think the rest of it you have done well, except just those limits. So yeah, it's fine even if you don't show me the working now. But I would encourage you to at least solve. Okay, so for this, the answer is for the variances part, for this guy, the answer is
Ma'am, I think I'm making some mistake again. Can you just clarify the subparts of it for me? The x into f of x dx part, is it coming as 6211.51?
wait, are you talking about the expectation part?
Yeah, of KT2.
So I've written the final answer. You just let me just subtract it from that because even I don't know I never solved such. Wait, let me see. So I know that your 5 to 9.5 is correct. Let me just check. Yeah, it should be somewhere about 6027.5. थोड़ा बहुत इधर उधर हुआ तो चल जाएगा. What did
How
you
is
get?
5 to 9.5 correct? Because again, it will be the same thing, right? Like f of 25,000. So I will need. Oh no. Okay. That part is right.
Yeah, that's correct.
Ma'am, I'm still making some mistake. I'm getting the answer as 6741.
6741. The total answer, final answer, you mean?
Yeah.
So let us walk through everything, okay? So let me just see a minute.
Can you tell me if my UK value is right? Is it 1.39?
UK. No, it should be 1.233.
1.233. So it will be log of L, that is 25,000, minus mu, that is 8.5 upon sigma. So that will be under root 0.64, right?
Is L 25,000?
Isn't it?
Check.
Retention limit 25,000.
Yeah, but is that your lower limit for the integral for which you are trying to figure this out?
No, I'm talking about the upper limit.
Wait, are we? Okay, yeah. Then it's, yeah. Then it should be 2 point. So what are you doing? You are doing log of 25,000 minus.
Oh, wait, I didn't take. Oh, I took sigma as 0.64, not under root 0.64.
Yeah. Isha,
Yes, ma'am.
are you there? Why have you still written as 0.64? Why are you still, I mean,
Uh,
I know your
yeah,
answers
I
are
just did
correct.
the calculation in the calculator. I didn't change it there.
Rest everything seems fine, Isha.
Okay, ma'am. I'm doing the variance part again. I'll send it to you.
Yeah, so I think I'm just going to, end our meeting for now. And you can send me the variance part. I have a call to attend, actually, today.
Yes, ma'am. I'll send it.
So does anyone else need any help? So just let me know on WhatsApp and it's no worries. And yeah, I guess you guys should revise, keep revising. I mean, had I known that this would be the situation, I would probably have taken a lecture during the week just to not lose you guys out of the loop. But yeah, no worries.
Ma'am, then what will be the timing on Sunday then?
What will be the timing on Sunday?
And
Very good
even I
question.
am okay with the class on in the morning on Sunday.
So let's keep it at 9. 9 sounds good. We'll have a class from 9 to 11. Okay, I'm assuming silence means yes.
Ma'am, can you make it 10 to 12, please?
Why?
If it's okay with everyone.
Why?
Actually 9 is okay for me.
Okay. Okay, let's keep it 10 to 12. I don't have any issues.
Thank you so much, ma'am.
Sleep well, I would say.
And can we keep it at 9 o'clock?
Oh, okay. So I don't know. You guys
Okay,
decide
no
the
problem,
timing
ma'am.
and just tell me.
No problem.
So let's keep at 9. Perfect. I'll put it in the group today. Okay, then. I'll see you guys on Sunday.
Ma'am, you are going to take a sum on Sunday, right? So is it going to be of
Yes.
chapter 1 or 2?
So now it will be of chapter 2.
Okay.
Yeah.
Thank you, ma'am.
And I think like chapter 1 sum wouldn't be, even much more difficult now that once you solve chapter 2's question. So yeah, you should be fine with it. And again, if you have any doubt anywhere, like छोटा से छोटा doubt भी रहेगा, तो please ask me. You have paid for these classes. And I'm here to solve your doubts. So, and again, I would highly encourage for you to put your doubts in the group so that not only me, but your peers can also solve through it. And I think it's only good because if one puts the doubt and the other solves it, it's like a revision for both of them and for the rest of them as well, who would see this particular doubt. And yeah, I think that is how we learn the best. So yeah, but it's fine. You can message me personally as well. Not a big deal. And yeah, that's all from my side for today.
Thank you, ma'am.
Thank you, ma'am.
Have a great week.
Thank you, ma'am.
See you on Sunday.